Welcome to this session of Learn with Slides. Today we are diving into a classic physics challenge, the circular motion question. Can you solve this problem by self? In this problem, we examine a ball starting at point A and traveling down a track into a circular loop of radius r. Our specific goal is to determine the velocity of the ball at the highest point of the circle, point B. We are working under two key constraints. One is, the track is entirely frictionless, and second one is, the ball barely makes contact with the track at point B. To solve for point B, we first look at the forces acting on the ball at any random position along the circular path. This Fc is the centripetal force that ensuring the circular path of the ball, and the N is normal force that acting on the ball by the track, and also M is the mass of the ball, and G is the gravitational force. We can express centripetal force by normal force and weight of the ball. Fc equals to the normal force minus mg cosine alpha. Alpha is the angle between gravitational force and normal force. And already we know from the theory the centripetal force equals to the mv squared over r. R is the radius of the track. Similarly, let we analyze another random point of the ball. In here, we can see centripetal force is the sum of the normal force and the component of weight acting toward the center. We now apply our general analysis specifically to position B, the very top of the circle. Now, the angle between normal force and the weight is 0. Therefore, we can express our equations like this, because the cosine 0 equals 1. In this question, mention that the ball contact point B barely. This is the critical condition of this question and the key of the solution. This indicates that the normal force at the point B is 0. This simplifies the equations as follows. Finally, we can see the calculations for the solution of the question as this. The minimum velocity required for the ball to maintain its circular path at the top of the loop without falling off, barely making contact, is the square root of the product of gravity and the radius. This capital R represents the actual radius of the circular path. We successfully determined the specific physical requirements for the ball at its highest point, point B. This concludes our session on circular motion. Thank you for your attention throughout this lesson.